Oh, hi there. I'm Dan,
I'm Zach.
and this is our physics project.
So Daniel, what do we have here?
Well, wouldn't you like to know, Zach? What we have here is a premium military-grade, industrial-quality, state-of-the-art ping-pong projectilization device. Now, if you're like me, that sounds pretty awesome, but if you're not, Zach can explain it to you in layman's terms.
Now when you pull the hammer back, it is stopped by a complicated stopper. When a ping pong ball is placed on one of these three divots, which will remain constant I assure you, and the hammer is released, it will launch the ball horizontally at a constant speed every time.
That's just splendid! To accurately calculate the distance that the ball will travel, what we had to do was find an average initial velocity of the ball. So, over a series of 15 trials, we took our ball, we hammered it, it flew a certain distance. We did that 15 times, and we came up with this table here. And as we timed the descent of the ball in seconds and the displacement in centimeters, we were able to come up with an average for both time and displacement, which leads us to this equation. Vx equals delta x over t. That gives us an average velocity of 2.025 meters per second. Alright guys, so basically we had to identify delta y, which is the total height of the ball. But wait, we have to take into account the height of the cup, which is 0.12 meters, and the height of this wood block right here. That also takes effect on the ball, and that's 0.04 meters. So, in other words, our delta y is the height of the table or counter, or whatever we have it on, minus 0.08 meters. Now that brings us to our next equation. Look familiar? T equals the square root of delta y over 1/2 g. That's what we're going to use. So, for this example, our delta y is 1 meter, the height of this counter, pretty convenient I'd say, minus the 0.08 meters as stated previously, gives us 0.92 meters. We have our initial velocity as calculated previously, and our force of gravity. Putting it into the equation gives us 0.433 seconds. That should be the time it takes for this ball to descend. Bringing us to our final equation. Very familiar. Delta x equals the velocity of x times t. So, plugging into that equation, we get 0.877 meters, or about 88 centimeters. Now, what we're going to do, we're going to take this here ruler, alright? We line it up with the ball and measure 88 centimeters on the ground. And we place this cup like so. Splendid. So after measuring our displacement and placing the cup accordingly, when we pull back this hammer and drop it, the ball should land directly in the cup. Check that out. Pretty rad. Tastes like science.
So according to the formula of displacement, we can land the ball in the cup at any height, as long as we plug it into the formula. Let's see if it works.
Yeah.
Delicious.
Same concept. That's one small step for students, one giant leap for ping pong balls. That's impressive.
It tastes impressive. The final test. It's about to get real. Dog just spilled our cup. It's all over the carpet.
Oh God. Peppy. You are a silly dog. Go.
It's about to get real.
It hit the cup. Go.
It's about to get real. Just kidding. Not gonna get real.